Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the lesson on solving more complicated equations involving exponentials and natural logarithms. This is the second example we're going to go through this evening. 2 to the x, e to the power of 2x equals 5. So just thinking clearly about what this means, it means 2 to the power of x times by e to the power of 2x equals 5. We're trying to find the value of x that makes that true. We're going to try and find the exact value of x that makes that true. Now, first thing that we're going to do, because we've got e involved in this equation here, we're going to take ln of both sides of the equation, and we are going to be using the relationship that e and ln are inverse of each other. However, what we need to do is just to deal with this in here. I've used a square bracket because what I have in here is I have the product of two things. I have two things being multiplied together. And what I need to do is to separate them out. And what I'm going to do is I'm going to use the log rule of the log addition rule, which is if you have log of A plus log of B, you are able to multiply those two numbers together to give you a single logarithm, log AB, provided of course those logs are to the same base. We can do that in this case because it's ln. So what I'm going to do actually, I'm going to reverse engineer that. So I'm going to think, okay, two things multiplied together, I could write as log of the first thing plus log of the second thing. So what I'm going to do here is I'm going to write it as ln of 2 to the x plus ln e 2 to the x equals ln 5. The right hand side of that equation hasn't changed. Now, a couple of things happen here. Bear in mind the journey I'm on, what I'm trying to get to. I'm trying to find the value of x, so I need to get to x equals. So this x here, using another rule of logarithms, which is the powers rule, I can move that x that's a power down to the front here. So I can rewrite that as x ln 2. Bear in mind, of course, that ln 2 is a number, so really what I have here is just a number of x. Now this bit here, ln e, you remember that ln and e are inverse functions of each other. So if I raise e to the power of 2x, and I then ln that, the ln and e are going to cancel each other out, they're going to undo each other, and I'm actually just going to be left with 2x. That still equals ln 5. I haven't changed anything about the right hand side of the equation. Okay, remembering what I'm after here, I'm after x equals, and on the left hand side I can see that I've got x appearing in two places. I want x on its own for my solution. So what I'm going to do now on the left hand side is I'm going to factorise x out. In my bracket I would get ln 2 plus 2. And at this stage I'm going to put a bracket round the 2 for the ln so that I don't think it's ln 4. It's ln 2 plus the number 2, which is separate, which still equals ln 5. So I now have x times by this bracket. This bracket is a number, which means that I can divide both sides of the equation by this number, and that gives me x equals ln 5 all over ln 2 plus 2. And that is my exact solution, because this is a number, ln 5 divided by ln 2 plus 2. I could type it into a calculator and get the answer to a certain degree of accuracy, but I want the exact value, so I'm done.